Hi friends, good morning. Friends, as in last lecture we have studied the velocity time relationship equation of motion. So in this session, in this lecture, we are going to derive remaining two equations, which are position time relationship equation and position velocity relationship equation. So friends, let's start. Today second equation is position time relationship. So the thing is, what is the equation of position time relationship? So this is the equation of position time relationship, is equal to ut plus half at square, where s is the distance, u is the initial velocity, t is the time, a is the acceleration. So we are going to find out this derivation through graphical representation method. Now what is graphical representation method, which already I explained in last previous video. So this will be remaining same, the graph will remain same. So this is the graph, see here, so this was the y-axis, x-axis, it's same graph I am repeating in like previous one. So this was the graph, and we consider as initial velocity u instead of 0. This was the graph. Now what we have to do, we have to think that where we will get this relationship. The main thing is how we will start. If once you start, if you know that where we have to start from which point, so remaining things it is going to come automatically. So we have to know the starting point where we have to start. So what we have to do, we have, as we know, this is initial velocity and this is the final velocity u and v. So under this graph, all that area which is covering this one, all this area, we have to calculate the position time relationship. So for calculating position time relationship, first we have to calculate the distance. Distance means below this area enclosed within the graph. This is the graph. We are not considering this point, okay? We are considering only area enclosed within the graph. So within the graph, this is the graph now. This is initial velocity, this is the final velocity. So what we are doing, we are calculating only the curve, the area which is under this line, okay? We are not going to calculate this above one, we are only calculating area enclosed within the graph, okay? So what we will do, as we know that S is the area enclosed within the graph, this is the graph, we have to calculate this area, okay? So how will calculate? We know that this area is A, O, A, B, C. So S is equal to area of rectangle. There are two, one is rectangle A, O, C, D, and second one is the triangle A, B and D. So what we are going to calculate, how we'll calculate, you tell me how we'll going to calculate the area of this under this graph. We are going to calculate this triangle area and this rectangle area, then we will add off these two and we will get the total area under the graph and close the graph. So what we are going to do, we are taking area of rectangle OADC. So OADC and area of ABD. When we will add these two area, we are going to get S is the total area enclosed within the graph. So what is OADC? OADC, as we know, the area of triangle is, so what is the area of triangle? This side OA, or you can take CD, the parallel this side or this side. So OADC is the AD plus AO, or else you can take AD plus DC, anything, because these are same. This is a rectangle, opposite sides are same, so we have to take opposite one side into this side. So this is the area of rectangle. And what is the area of triangle? As we all know, area of triangle is 1 by 2 into base into height. So 1 by 2 into base is AD and height is BD. This is the height. So area of rectangle and area of triangle, we are going to add these two and we are going to get the area enclosed within the curve, within the graph. Now what is AD? AD is this one, right? AD is what is this? AD. AD is what is this? OC. AD equal to OC equal to time. So instead of AD we are going to put T. And what is AO? AO is this one, is the initial velocity U. Similarly 1 by 2, what is AD? AD is this one, time. Okay. Now what is BD? BD we don't know, so let it be like that. Okay. See, instead of AD we took T, AO is U, half AD is T, and what is BD? As we know how we get this AD, in the first lecture I have told you that BD is AT because acceleration equal to change in velocity upon time. There I got AD instead of BT. Okay. So here S equal to UT plus half AT square. Hence prove. See, S equal to UT plus half AT square, S equal to UT plus half AT square. When you multiply these things, so you will get, this is UT, this will become UT, this is half, and there is 2t, so AT square. So S equal to UT plus half AT square. This is the position time relationship equation of motion. So you know where we got this AT? AT we got from the equation number 1 in first previous lecture. Okay, because we know acceleration equal to change in velocity upon time. So we got, instead of BD we took AT. Similarly, next we will calculate third equation, which is position velocity relationship. If you have any doubt, you can comment me on the comment section. So let's start with the third equation of motion, which is position velocity relationship. In this we don't have to do anything. We are going to calculate the same thing as we calculated in the previous equation, which was position time relationship, and this is position velocity relationship. So what we will do, we will do the same graphical representation, only the equation will vary. What is the equation? Position velocity relationship having equation called 2as equal to v square minus u square. This is the equation of motion, of third equation of motion. V square minus u square equal to 2as. So first we will draw the same graph. This is the graph. Okay. Here what we have to do, again we have to calculate area enclosed within the graph. The same thing I have to calculate in this section also, but there is one changes. In previous position time relationship equation, we have seen that we took this area by adding these two areas, rectangle and triangle, but in this position velocity relationship we are not going to calculate rectangular and triangular area. We are going to calculate the total area, which is O, A, B, C. is this OABC. What is this? This is a trapezium, right? See, OABC. What is this? This is trapezium. So what we are going to calculate? We are going to calculate area of trapezium. See, in position time relationship we have calculated area of triangle and area of rectangle, and we added it and we got the equation of position time relationship. But in position velocity relationship we are going to calculate the area of trapezium. So how we'll calculate? Let's see. This is the trapezium OABC. So we know the formula of trapezium is equal to sum of parallel side. This is the sum of parallel. What is the parallel side? AO and BC. See, this is the parallel line now. BC and AO. Sum of parallel line divided by 2 into height. What is the height? Height is this OC. OC is the height. Or you can calculate H. So when put sum of side, what is sum of side? AO plus BC divided by 2 into height. We can write instead of height OC. This is the height now between two parallel lines. This parallel line, this parallel line. This is the height. Okay. Now what we will do, as we know that S equal to, we will put instead of AO, where is AO? This AO is initial velocity U. Similarly, BC is the final velocity, which is V, divided by 2 into OC. What is OC? OC is time. Time. So U plus V divided by 2 into time. Friends, as we studied in previously, that acceleration equal to final velocity minus initial velocity divided by time. So what we have to do, we have going to replace this t. Now the question is, why we are replacing this t? Because we have to get equation in this form where there is no requirement of time. So what we are going to do, we are going to replace this time from this formula, acceleration equal to V minus A divided by time, or else you can say time equal to V minus A divided by A. So what we are going to do, we are going to put this value instead of t. So see, S equal to U plus V divided by 2 into V minus U divided by A. Instead of t, we just put this thing, so minus U. Now when we will calculate, so we will get final equation 2s equal to e square minus u square. You can see 2 is here, a is here, s is here. So cross multiplication, we will get 2as equal to v square minus u square. So once again, I am going to repeat it. See friends, what we have to do, in position time relationship, we have calculated the area of triangle, area of rectangle, and we both added this and we got the area of this total enclosed within the curve. But in position velocity relationship, we are going to calculate the area of trapezium, which is OABC. So area of trapezium, we know the formula, sum of parallel side divided by 2 into height. When we will put the sum of side, this is the side of parallel side AO, this parallel line, and this BC, this is the parallel line, divide by 2 into, instead of height you can write OC or time. So directly with this OC or time. So now instead of AO is the initial velocity U and BC is the final velocity V. So what we got this thing. Now we have to replace t by initial and final velocity, because we have to get the equation in this form. So we know that A equal to V minus U by t, rt equal to v minus u by a. So we are going to replace this t by this one. So we'll put this one and we'll get this equation. So friends, this is the third equation of motion. So hope you enjoyed the video. If you have any doubt, you can comment in comment section. I'll explain it. And if you like the video, just thumb like, share to your friends, and don't forget to subscribe. Thank you friends.